Hello to everyone, and thank you for joining us today. My name is Marius, and I'd like to welcome you to today's Oracle Advisor webcast titled Oracle Advanced Queuing Features and Administration. Our speaker today is Ragul Ramdas, who is a Senior Software Engineer. We also have Jaya Krishna Paturo and Kanti Kiran Kurapati, Senior Software Engineers, joining us as panelists for the Q&A session. We expect today's webcast to last approximately 60 minutes, including a brief Q&A session. This session is being recorded. At the end of the session, I will go over when and how you can access the recording and the question and answer from the webcast today. Questions can be submitted to me throughout the presentation via the chat or Q&A panel. Your questions will be collected and read aloud during the Q&A portion of the call in the order they are received. To aid in question collection, please only submit your questions once. If you are listening via voice streaming and lose sound, go to Communicate Audio Broadcast to restart the audio streaming. Should you still encounter difficulties, please dial into Intercall directly using the numbers provided in your reminder emails. Any questions that remain unanswered at the end of the session will be transferred to the community, where you can continue the conversation. What you see on the screen now is a reminder that this Advisor webcast is intended for information purposes only. Any features or functionality described for Oracle's product remains at the sole discretion of Oracle. Now, let's get started with our presentation. Ragul, if you are ready, I pass over the presentation to you.
Thanks, Marius. Hello, everyone. Thanks for joining the webcast today on Oracle AQ Features and Administration. Myself, Ragul, working in Oracle Global Customer Support, will present the webcast. So we'll quickly move on to the agenda. So this is the objectives which we are going to review today. So we'll be reviewing the architecture of Oracle AQ with the features. So how the queue tables are created, what are the functionality of different types of queues available in Oracle Advanced Queuing, and we would see certain recommendations on how to improve the performance in Oracle AQ. So the agenda here would be on the single consumer queues, multiple consumer queues, exception queues, and on the performance prompt. So Oracle AQ. So Oracle AQ, it's a vital feature nowadays. So how it helps is like moving the messages from a source queue to a target queue. So moving of messaging, or this is a simple messaging system where we can get notification as well. So Oracle AQ provides the message management functionality which is necessary for the e-business integration. Oracle AQ was first introduced in Oracle 8, and it was enhanced and extended in the recent versions. So what is queuing? So queuing, it is the ability to send the message or enqueue the message from the source queue to the target queue, where the message will be dequeued or received. So this basically works on the publisher and subscriber logic. A publisher would give a message, and that message it will be received in the target end by a subscriber. Oracle AQ supports only asynchronous messaging, and it does not support synchronous messaging. So at a time, you can't have the same message on both the source and target queues. So this is what asynchronous messaging is. So message, it will be stored into the source queue, and it will be propagated to the target queue in a particular time. So moving on to the features of Oracle AQ. So Oracle AQ, it supports the usage of Oracle Streams from Oracle 9.2 and above. Oracle Streams, it was one of the replication engines available with Oracle, which is now replaced by Oracle Golden Gate. So here, Oracle AQ, it was supporting the Oracle Streams logic, and all the APIs were dependent on the Oracle AQ's APIs. Oracle AQ supports distributed applications. You can use batch processing of messages like bulk load also Oracle AQ accepts. AQ supports the use of buffer messages from Oracle 10.2 and above. So here we do have the concepts of buffer messaging and persistent messaging, which means like buffer represents operating from in memory, and persistent messaging which would be reliable on the disk. So with related to the buffer messages like we would be reviewing in the future slide. Oracle AQ provides broadcast messaging, which means like one-to-one messaging is also possible, which means like one publisher and one subscriber logic is also possible, and one publisher and many subscribers. This kind of one-to-many logic is also possible in Oracle AQ. AQ provides different modes of propagation, so we can use database link to connect between two databases, and also we can use middlewares like the JMS, gateways, SOA, EBS suites. So those middlewares also work based on the logic of Oracle AQ, which will be having Q2Q logic. So there are two modes of propagation, basically using DP-Link as well as like using the Q2Q logic. AQ supports error handling. So we have Oracle AQ has like well-defined dictionary tables or dictionary views which can help in the error handling logic. AQ supports the usage of multiple payload types like AnyData, JMS, RAW. So this is the payload like which would be used in the messaging system. Messages can be customized with the order of dequeue. So suppose I have a message which is enqueued at around 1 o'clock, and if I need the message to get dequeued after 10 minutes, so I can specify a wait time, and after 10 minutes that message would be dequeued. So that logic is also possible, as well as like based on the first in first out logic. So whichever message comes first, so that should be dequeued first. So first in first out logic also it is possible. Oracle AQ can listen for the available messages. Oracle AQ can listen for the available messages through DBMS AQ Listen. So this is a package available, and AQ Listen, it is used mostly in the case of multiple subscriber queues. So this AQ Listen ensures that no message has been left into the subscriber unattended. So notifications can be achieved via email. AQ logic supports the use of notifications, so which means like whichever event is triggered, you can get notification through an email. So that logic is supported by Oracle AQ. Messages can be transformed using DBMS transformation API. So here, assume that we have two applications or databases. So the message format in database 1, it won't be the same with that of database 2. So the message which is passed on from database 1, it would be transformed into a viable format in the database 2. So this can be achieved by using the DBMS transform API. And again, we do have well-defined APIs for both PLSQL and Java operations. So the mostly used and most basic APIs are DBMS_AQ admin and DBMS_AQ. So whichever AQ user is configured with DBMS AQ admin or DBMS AQ should have the privileges to access. So this is a workflow diagram of Oracle AQ. You can see an AQ administrator, which will be administrative user, which will be having a create queue. So where the queue would get created and started, and the NQ operation would happen from that particular moment. So whichever queue is available, so it will be having the messages enqueued in it, and those enqueued messages it will be dequeued automatically through the callback procedure. So this is the pictorial representation of the workflow of AQ. So a PLSQL callback procedure would be registered. So, and publisher enqueues the message onto a queue. So here it represents the source queue. Publisher always would be available on the source end. So a message would be made available into the queue. So once a message is available, EMON, which means the event monitor background process, is posted by the enqueue session. So EMON would be notified that a message is available for the enqueue operation. So in this case, a job would be created automatically. So this job, it would be a similar kind of Oracle job. but an AQ job. So this will carry out the DQ operation. So the job queue process DQs the notification and executes in the specified target queue. So moving on to the AQ components. So here we do have different objects associated with the Oracle AQ. So we'll first look into the terminology. So queue, always a queue, it is known as the integral part of AQ where the messages are stored or enqueued. So queue will be always having the messages, and queue table, it will be the collection of queues. A single queue table can have either a single queue or else a multiple queue. So single queue and multiple queue is also possible with the queue table logic. So the next important AQ object would be the payload. So here the payload refers to the data part of the message. So what type of message should be stored, it will be defined in the payload, and the payload need to be created before the creation of the Oracle AQ queue table or a queue. So message is the data sent from the application or the database. So whichever data is passed, it is called as a message in an AQ. Publisher enqueues the messages to the queue. So publisher is the one which makes the message available, and subscriber, it is the recipient of the message, and subscriber only dequeues the message, and it refers to the target queue. So what are the types of queues available? So there are multiple queues available based on the functionality. So single consumer queues, multiple consumer queues, exception queues, buffered queues, and persistent queues. So quickly moving on to the single consumer queue. So as the name suggests, it is based on a one-to-one logic. So there will be one source queue, and in the target end there will be one target queue, which means only one subscriber or a consumer. So once the message is made available to the DQ, the target queue dequeues the message by executing the callback procedure. So once that is done, the messages would be removed. Messages in the single consumer queue table can be dequeued only once. So Oracle AQ doesn't support the logic of duplicate messages. So only once you can dequeue the available message. This is faster when compared to the multiple consumer queues, since there is only one dependent target available. We can manage the single consumer queues based on the DBMS AQ admin, which is used to create a queue table or alter the queue table or create a queue, stop the queue, start the queue. So any type of operation would be mostly possible by using this DBMS_AQ ADM package. So using this, we can control the queues or queue tables. So here is the example or a syntax for the creation of queue table. So we would be using the DBMS_AQ ADM package. So in that we would be having multiple parameter lists. So but the basic needs are like you need to define the queue table name and the queue payload type. So what type of message it should carry, so that we would be defining in the payload. So that is needed to create a queue table. So by default in Oracle, a single consumer queue table is created always. So here is the pictorial representation for an example of single consumer queues. So here I am having two source, application A and application B, which are producing the messages, and they are putting together into a single queue. So here the source queue is 1, which means the queue 1. Only one queue is available, but both the applications A and B are putting the messages into it, and currently there are 4 messages. So these 4 messages, it will be dequeued by the application C, which are running with instances 1, 2, and 3. So here we have one-to-one propagation, which is like kind of single consumer queue. So the source queue is 1, and it is dequeued by the target queue in the application C. So here we are able to see a list of objects. So the first image, it shows the objects created once a queue table is created. So here I have created a queue table in the name local_queue_table, and these are the basic objects which will get automatically created. Each and every object, so which is mentioned over there with view, queue, there are certain indexes available, there's a table available. So all these will help in the normal functionality of Oracle AQ. So the first image, it shows the object list once the queue table is created, and the second image, it shows the object which are available once the queue is started. So once the queue is started, we will be having certain LOBs and sys indexes, so which will help in the Oracle AQ flow. So here is the explanation for certain objects which were created. So you will be having an object with _e. It represents the exception queue table. So the exception queue table will come into picture whenever a message is not reachable to the target. So when a message is not capable of reaching the target, in that case, the messages would be put into the exception queue, which can be later reutilized. So you will be having an object with the actual queue table name. So that will be the actual queue table, which will be having the multiple queues in it, defined based on the operation logic. So the next object which would be available is with _i, which represents the DQ index. So this will be having the metadata information of the DQ indexes available for that particular queue table. So next object available would be with _f, which is a view to show the conditional DQ of objects. So if any object is DQ'd with a condition, so that metadata information will be available in the _ef view. So the next object which would be available is with _t, which is the time manager index. So here, information like, or the metadata information like at what time the message was DQ'd, how much time the message was available in the queue, at what time the message was DQ'd, which is the first message which was enqueued. So all those information, it will be available in this _t time manager index object. So here is a sample code which will show the enqueue operation, or how the enqueue operation happens with a message of raw data type. So here you can see we have used the dbms _aq package. In that we have used the enqueue procedure to enqueue the message. So there we have defined what is the queue table, or the queue name from where the message should be fetched. So from this queue, the messages would be fetched by the register job, which would be created, and that particular message, it will be passed on to this particular DQ end. So here is a sample code which shows the DQ, or how the DQ happens. So here we have to define the target queue name, so where the message is available. So message should be made available. So here we are utilizing the dbms _aq.dq procedure. So moving on to the multi-consumer queues. So here a queue can be defined as a multi-consumer queue if it has multiple recipients or multiple subscribers. So as we know, AQ works on the logic of publisher and subscriber. So a publisher can be one, but on the target end, we can have multiple subscribers to subscribe for that message which is published by the publisher. So this is the logic of multiple consumer queues. So we have a syntax available. We can make use of the dbms _aq ADM package to create a multi-consumer queue table, and there is a parameter with multiple _consumers that should be set to true, and that only defines that the queue table would be a multi-consumer queue table. So here is a pictorial representation for multi-consumer queue. So we can see that application A and B are putting the messages into a queue1, and we have around 4 messages available, and at the DQ end, it is DQ'd by 3 applications. Application C, application D, and application E respectively are DQing the messages. So all the 4 messages would be made available to the application C as well as application D and application E. So this is the workflow logic of multi-consumer queues. So once when we create a multi-consumer queue and when we start it, so these are the objects which should be made available, which will help in the workflow of the multi-consumer operation. So we'll discuss one by one. So we'll be having a object with underscore G, which represents the signature. So this underscore G, it is an IOT, which is an index organized table. So at present, like, we are not having any implementation on it, but it is used to refer to the signature. The next object, it will be with underscore I. So the underscore I object, it is an DQ index, which will be having the multiple consumer queues DQ operation or the metadata of it. The next object is with underscore T, which is the time manager index, and it is used for queue monitor operation. So here also, like, all the when was the message enqueued, the time would be available. When was the message dequeued, that particular time would be taken care, or the metadata information would be stored in this time manager index. So we'll be having an underscore H object, which represents the history. It is an index or an index organized table for storing the DQ history. So this is only available for the DQ operation. So the next object would be with an object with underscore P, which represents the spillover queue table. So it is used to store the events that are spilled from memory. So here, whenever there is inadequate memory to process the AQ operations, so the messages would be spilled onto the disk, and that events would be having the metadata available in the underscore P queue table. So we'll be having an object with QT, which is the actual queue table, and there will be the next object with underscore S, which represents the subscribers or subscriptions. So it is a table which will be used for storing how many subscribers are there and the subscriber metadata. So this, it will be absent in the single consumer queues, because in single consumer queue we'll be having a single subscriber available, and here we'll be having multiple subscribers. So next is an object with underscore V, which represents the evaluation context. So this evaluation context, it is used to evaluate the rules. So we are having another object with underscore R, which represents the rules. So whichever rule is defined for the queues, it will be having the metadata and the underscore R, and to evaluate that rule, the underscore V evaluation context, it will be used, and it is an IOT. So the next object, it will be with an underscore C, which represents the commit time IOT. So it will be having the transactionally grouped multi-consumer queues with a commit time order. So at what this has the metadata information based on commit. So these are the objects which would be available with the multi-consumer queues. So here is the code which would be helpful in the enqueue operation. So first we need to add the subscribers. This step, it will be absent in the single consumer queue, but here in the multiple consumer we need to define agents for every subscriber. So assume that here I am having 2 subscribers, so I am creating agent 1 and agent 2, which is logical, and I'm adding subscriber with it. So agent 1 will be for the subscriber 1, and agent 2 would define the subscriber 2, and then I'm enqueuing the message using the code available. So here also I would be using the dbms underscore aq dot enqueue procedure. So here I would define the queue name, and that queue name it will be calling on to the subscribers. So once a message is enqueued, it will be available in the actual queue, and during the DQ end, we need to call the agents one by one using the similar kind of procedures available. So here, when agent 1 is notified, the message would be DQ'd to the subscriber 1. Similarly, when the agent 2 is being notified, the dbms underscore aq dot DQ procedure will invoke the queue operation, and the message would be made available to the subscriber 2. So this is how the DQ works in case of multi-consumer queues. So when the messages or during the workflow of the message, we can identify what is the state of message using the different message states available. So we'll be having messages with state 0 or the ready, which means the message is ready to be processed and it is made available to the DQ. So that is what a ready state represents. So the next would be a state with waiting or wait with state 1. So here it represents that the message is waiting for the dequeue to happen, and it could, one of the reasons for the waiting state is it could be like a wait time has been specified. Suppose I need the message to be dequeued after 10 minutes, so that in that state the messages would be available in the waiting state. So the next available message state is retained or processed, which is a state 2. So this state represents that the message has been successfully dequeued by the subscriber or subscribers, but it is yet to get cleaned up by the QMon process. So QMon, it is the queue monitor process which will be helpful in the Oracle AQ operation, and this is the background process for the Oracle AQ. So that QMon process will spawn and it will do the cleanup operation for the processed messages. Next, the expired state or state 3. So this shows that due to some reason the message is not able to get dequeued successfully by the subscribers, and it will try for 16 times. So even after 16 times, if the target queue is unreachable, then the messages would be put on into the exception queue and the status of the message would be expired. So moving on to the exception queues. So this is one good feature available with Oracle AQ, where whichever message which got errored out or whichever message didn't make to the target queue, after a retry of 16 times, it will be put on to a separate queue table. So that queue table, it would be noted with an _e. So it is a exception queue. So this queue, it will be having all the exception messages available in the expired state. So the best utility of this exception queue is that we can re-enqueue the message which got expired. So if we are in need of the message which got interrupted due to some network error, assume like that, due to some network problem, the message got interrupted and it got moved on to the exception queue, and I need that the particular message or the data. So in that case, I can dequeue the message from an exception queue. So this, to perform this operation, we can make use of the code available in the mentioned doc-id. So using the code available in that particular note, we can be able to dequeue the messages from the exception queue. And from the performance end, accumulation of the expired messages in huge numbers, it would be creating an overhead and it will create performance issues in the Oracle AQ. So it is always good to clear the expired messages or to consume, or else like either we can clear it. So this should be done from the performance end. So here is the syntax on how to create a exception queue. Once a queue table gets created, a default exception queue would be created automatically. So this is as per the architecture, but if we need a separate user-defined queue table, we can also create it. So suppose assume that if I need my own exception queue table, so I can create the queue using the queue name with an E for an identification, and the queue type, it should be mentioned for exception _ queue. So in the queue type, that is one important parameter here which defines how the queue should work. So here, since it is mentioned as dbms _ aqadm.exception _ queue, so it means that this particular queue will work as an exception queue. So this is kind of user created for our custom purposes. So there's a pictorial representation. So Q1, it is having 10 messages. Q2, it is having 7 messages. So due to some reason, there are a shortage of 3 messages in Q2. So those 3 messages then got propagated to the target queue, and it will try for 16 times to reach the target queue. So if in case it is not able to reach the target queue in 16 attempts, then the message will be put into the exception queue. So this is the logic of exception queues. So how to handle exception in the multi-consumer queue? So as we know, the multi-consumer queue, it has multiple subscribers available. So here also the message would be made available in the exception queue. if the message is not able to be dequeued successfully by the intended subscribers. A message is considered expired if one or more consumer did not dequeue the message before the expiration time. So this is one important point here. A message is considered as expired if one or more consumer did not dequeue the message before the expiration time. Again, the expired messages can be dequeued only once. We can have the check of how many expired messages are available by querying the _eq. So next, buffered messages. So buffered messages, this is available from Oracle 10.2. So here the word buffered in the sense like it will be operating from memory. So which means like the queue, it will be working from the SGA. And buffered messages are stored in the SGA. It can be spilled to the queue. Suppose in case the memory is not available, then it can be spilled to the queue table, which will be available in the disk. So this here comes the logic of persistent queues. Persistent queues always operate from the disk. Buffered messages always operate from the memory or the SGA. So these messages, it would be lost once if an instance restart is done, since it is operating from memory. But from the performance end, operating messages from the buffer or the SGA, it would be good when compared with that of the persistent queues. So always buffered messaging would be more quicker and the performance would be great with buffered messaging. So this is about the overview of Oracle Advanced Queuing Objects and the workflow. So now moving on to the troubleshooting and performance end. So here we'll start with the parameter and the background process available for the Oracle AQ. So we have around like 3 parameters mostly used, which would be helpful in the Oracle AQ performance. So first parameter would be the stream spool size. So we need to have a minimum of 250 MB, which would be helpful in carrying on the Oracle AQ operations. So the next parameter is AQTM process. The AQTM process from 11.2, it should be set to 1. So this is the background, this is the parameter which controls the background process QMon or the Q monitor, which is used for AQ operations. So the next parameter would be job queue process. So this should be set to around 100, most recommended, but with 50 it can work good. So this job queue process, it will be helpful in carrying the Oracle AQ propagation job from the source queue to the target queue, which ensures that the message is propagated to the target end. So as we know, like we will be using debuilding for this operation. So QMon is the background process for the AQ operations. Setting the above parameters to the recommended values will ensure QMon's functionality. And job queue process ensures that no AQ jobs get failed during the propagation activity from the source queue to target queue. So coming to the rack, rack is all about high availability of the data and load balancing. So when it comes to Oracle AQ, even the load balancing would also be needed. So assume that like I'm having 2 instances. So whenever instance 1 goes down, the Oracle AQ services should automatically shift to the instance 2, which is available and running. Since rack is all about the high availability of data, every AQ table which is created in a rack environment will create a service effectively. For load balancing, we need to set instance affinity, which is available from Oracle 8i. So this is one good feature available from Oracle 8i. And the Oracle instance affinity should be defined for the AQ. So we'll move on to the instance affinity. So here, what does instance affinity means? Like we are just defining the primary instance for the Oracle AQ to carry out its operations. So we can set the primary instance as one instance. So whenever that particular instance goes down or fails over, so all the services will be switched to the secondary instance, which would be we'll be defining in the during the creation of QTable, or else like later on also we can create it. So for achieving this feature, ensure that the QTable parameter or the Q parameter is set to compatible 8.1. So this is a QTable compatibility and not the database compatibility. So you need to ensure that it is set to 8.1. This ownership failover and again the fallback logic, it will be taken care of by the QMon process which are running on the respective nodes. If in case I have a QTable created and I need to alter the QTable with this primary instance and secondary instance affinity, I can make use of the dbms aqadmin.alter_q_table, where we'll be defining the instance affinity once the QTable gets created. So here's the representation for the failover in 2-node environment. I'm having two QTables, QTab1 and QTab2. So both the QTables are created with the owner instance 1 and 1. So both the QTables were created in the instance 1, and we haven't defined the primary and secondary instance. As you can see from the representation, it is mentioned as 0 and 0. So now I would be configuring the QTab1 with the instance affinity. So we can make use of the dbms aqadmin.alter_qtable procedure. So for the QTable QTab1, it is defined as primary instance should be 1 and the secondary instance is 2. So when instance 1 crashes, the QMon on instance 2 takes the ownership of all the QTables. So here you can see the owner for QTab1, it has been changed to 2. Even for the QTab2, the owner it shows as a second instance, but check the primary and secondary values, it is still showing as 0 and 0. So when this instance affinity comes into play, so this happens once during the ownership fallback. Now my problematic instance 1 is available and is up and running. So in this case, the QMon will automatically shift the instance affinity from the secondary instance 2 to the primary, which is defined as the instance 1. So this is how the instance affinity helps whenever a particular instance or a node becomes unavailable. So the instance affinity, it will switch the services to the available instance, and when the instance or the problematic instance comes up, it will again switch back the ownership to the actual owner where the queue got created. This is defined on the values which is passed for the primary instance and the secondary instance in the QTable procedure. So the next issue is how to handle high watermark on Oracle AQ objects. So we have two methods available to bring down the high watermark. So we do have many SRs with this high watermark issue. So a particular segment belonging to any QTable can occupy a large amount of memory. So in that case, like we can do the string space available. So we can just do the alter command, alter table, that particular table, either the actual QTable or the tables with _I or the views with _T, _H, or the LOB segments. Anything can become can reach the high watermark and can give issues on this. So here we can just give those objects with the alter command and shrink it. So this is one option available for bringing down the high watermark. And the other option would be to use the dbms redefinition package to move the QTables during online, which means like when the AQ operation is happening, at that time itself you can do this redefinition from the available table space to another table space and bring it back again to the original table space. So this activity will help in reducing the high watermark. So this is again discussed in the MOS note 1410195.1. So this particular note has the complete steps to perform the redefinition from the available table space to the other tables and then bring it back. So this will help in reducing the high watermark. So the next performance recommendation is to coalesce the Oracle AQ objects available. So every AQ environment, which is every Oracle environment which is configured with Oracle AQ should be coalesced periodically, or like assume at least once in a week. So the Oracle AQ environment should be coalesced. So this will help in maintaining the NQ-DQ performance. It will reduce the QMON CPU usage, and it will help in the index maintenance of all the associated IoTs available for a particular Q table or the Q objects. So this from 11.2 onwards, the QMON process generally makes the maintenance activity. But for manual coalescing, always support advises customers to do a manual coalesce. For manual coalescing, Oracle support has provided a script with aqcoalesce.sql, and this particular script, when you run it, it will DQ all the objects which got created. It will coalesce all the objects which got created during the Q table creation. So objects like mostly the indexes, IoTs, and other dependent objects like views. So those will be coalesced. So all the indexes would be rebuilt as an activity of coalesce. The indexes would be rebuilt. So this will automatically help in bringing down the performance of Oracle, boosting the performance of Oracle AQ. To make this happen, ensure that the parameter _AQ_TM_scan limit is not set to a 0. So once if this underscore parameter is set to 0, it means that the coalescing is by default disabled. So ensure that you have a non-zero value available for this particular parameter. So this is further discussed in the MOS note, and the queue is available how to coalesce the objects, the particular aqcoalesce.sql. It is available in this particular note 271.855.1. So this coalescing, it should be done periodically, at least once a week or once in 2 weeks it should be done. So this ensures all the queue operations, all the Q1 activities are taken care. So as a summary, we have covered the considerations of Oracle AQ, the features available, what are all the types of queues available, exception handling and significance, and we have seen some performance recommendation on the AQ end.
Thank you, Ragul. We're going to open the Q&A in just a moment. Please use the Q&A panel or the phone line to ask any question. You can send the questions via Q&A panel on the Webex screen or press *1 if dialed in on the phone. While we pause to collect your questions, I'd like to share some helpful information. We'd like to invite you to stay connected with Oracle support via our various social media channels listed here. We have the Oracle database communities where you can post your questions and converse with subject experts and peers from other companies. My Oracle support blogs where you can keep informed about our priority announcements. Let's quickly cover each of the elements and their supporting icons that you will see throughout your learning experience working on My Oracle Support Portal and Cloud Support Portal. Online help documentation can be found from the help link on most pages on the portal pages. With the Oracle Support Essentials webcast, you'll learn how to best use the support portals, My Oracle Support and Cloud Support Portal, and provides tips and tricks on how to effectively work with Oracle Support. Oracle Support video series provides you with a repository of detailed training videos. Oracle Support Accreditation delivers a targeted learning experience to increase your expertise with support portal core functions and product-based support tools. As an Oracle Premier Support customer, you have access to a wealth of powerful resources to help you proactively manage your business. Use document 432.1 to get proactive and prevent issues and to contact the team responsible for proactive programs. You can also get a complete view of upcoming events with the Get Proactive Events calendar. The Proactive Support team sponsors a wealth of proactive support activities, including advisor webcasts like this one. You can get a complete view of coming events and activities with the Get Proactive Events calendar shown here. This calendar is automatically updated to include currently scheduled advisor webcasts, user group sessions, most essential trainings. You can filter the visible activities according to the Oracle software products most relevant to you. Look at documentation for more details, but you can also set up the calendar to display based on your time zone, and all of the event start times will update accordingly. Take advantage of the calendar to find sessions that will help you better utilize your products. Now we're going to open up for questions. Operator, are there any questions?
And again, that is *1 to ask a question. And we have no questions at this time.
Thank you. We have a written question. Can the Qualys.SQL be performed when the AQ is running or online?
Yes, the script is designed to collate the AQ IoTs even when they are online. So there will be no issues with performing the collace online.
We have another written.
Sunil Kumar. Actually, I have a query saying that if the messages are in queue, like, do we have any options saying that to send any specific message in priority from the queue?
Yes, we can define the priorities like based on the first in, first out or the commit time priority. So we can define those priorities during the DQ operation.
Procedure.
So based on that, yeah, using the
Okay.
DBMS AQ admin procedure. So it is available. So you can check the message underscore properties. There would be a package available with message underscore properties. So there we can define the properties, how the message should be DQ'd. So based on that, it will be automatically DQ'd in the subscriber end.
Okay, so you have mentioned like the expired queues will be in the table. So once if it is reboot, the expired queues also will be cleared from the queue, right? Or we need to clear it manually?
No, we need to clear it manually because like that expired or the expiration queue logic, like it will get automatically cleared only if you are operating from the buffered. So which means like if you're operating from the buffered memory, so in that case, it will automatically get cleared. But mostly in real time, we are using persistent queues. So in this case, messages will be stored in the disk. So here, automatically it don't happen. We need to manually purge the messages, or if needed, we can again re-enqueue the messages using the re-enqueue script available with Oracle support.
So you mentioned earlier saying that there is single consumer and multi-consumer. So by default, Oracle uses by default a single consumer. So why not multi-consumer? So is it any specific reason for that? I mean, as it is a basic, so Oracle recommends as a basic, or how it is?
No, it is just a default thing available. There is no logic behind this. So Oracle,
I mean,
you create
as compared to single consumer to multi-consumer, so we have major options at multi-consumer. So I mean, if it would be great that if Oracle gives an priority by default to the high users of the feature. So I mean, what I would feel like. So for that, what do you suggest?
I do agree. Like there are more enhanced features available with multi-consumer queue, but most of them won't prefer to it. Like by default, it can be given with the basic availability of the product. So the default thing, it will be available with the basic availability, and if needed, we can again customize based on the requirement. So that customization, it can be done with the multi-consumer queues. So there is no logic behind this.
Okay.
Thank you. Another question that we have, a written one. Is there any option to monitor queues from Oracle Enterprise Manager?
Yes, we can monitor the queues from Oracle Enterprise Manager, but regarding the tabs, like I can't be sure now, but we can discuss in the community, like based on this, like where in the Enterprise Manager page we can monitor the activity, so that we can take it offline.
Thank you. Another written question. How can one handle corruption in an AQ environment?
Okay. Based on corruption, like it depends on the availability of message. So if there are ready messages in a queue and it got corrupted, in this situation, like we have to recreate the queue and queue objects. So mostly the ready messages, it should be manually dequeued if needed. If the customer or client says that we can purge the ready messages, then in that case, like we can purge the ready messages and we can recreate the queue and queue table. This is one logic available. The other one is we can have we can create a user-defined or the custom queue, custom table. So this is just a normal table, not the queue table. So whichever message is available in the actual queue table, it can be copied onto the database table, and once after recreating it, we can again put the messages back into the queue table from the database table which was created temporarily. So this will ensure that there will be no messages lost. So there will be no data loss in this. But we need to create a table with create table as select from the actual queue table command.
Thank you. Are there any other phone line questions at this moment?
And you do have a question from the line of Siva.
See, hello.
Hi.
This is Shiva. At any given point of time, AQ will break FIFO order, first in, first out?
No, it can't break automatically. Like either the propagation should break, or else there should be some network issue. So due to that only, like it can break. And once it is back, then it will follow the setting first in, first out order. It will automatically dequeue based on the F5, F4 logic. So it will automatically resume.
Okay. So it will always follow first in, first out, right?
Yeah, right. So it depends on the message property which you have defined. So the order of DQ, how it should happen, it can be manipulated by using the message underscore property. So this is one procedure available with the DBMS underscore AQ admin package. So in that, like using that, you can manipulate it, whether first in, first out, or based on the commit time you need, anything you can do it. Once after, in case of any failure, once the failure is clear, it will automatically switch to the normal operation, either in the first in, first out order or anything else. Yeah.
Okay, thank you.
Yeah.
Thank you. Another written question. It was mentioned in the slides that accumulation of expired messages is an overhead. So how can we handle these expired messages?
Right. So this is a similar question which was asked by Sunil earlier. So here we have two options. So either we can re-enqueue the messages which got expired from the exception queue. So we can reconsume it if it is needed. So this depends on the customer. So if customer is very keen in consuming the messages, so once after the failure, it should get cleared off. And if the failure is corrected, in that case, like we can re-enqueue the messages or from the exception queue so that the actual queue can consume it and it can reach the target. So this is one thing. If the message is not needed, suppose like we do face issues when the exception queue will be having around thousands of messages accumulated. So in this case, performance issue would be seen in the Oracle AQ environment. So in this case, the best advice would be to purge the queue table, purge the exception messages by purging the exception queue. So this will help in avoiding the performance bottleneck.
Thank you. Another written question. Can AQ listen be used on non-persistent queues?
No, this particular AQ listen logic, it is available only for the persistent queues and it is not available for the non-persistent queue or the buffered queue. So AQ listen, it is always for the persistent queues.
Thank you. Are there any other phone line questions at this moment?
And there are no questions at this time.
Thank you. We still have written questions. Can AQ do multiple instances at once for load distribution? Sorry for that, everyone.
Please go ahead, sir.
Are there any questions?
Yes, another written question was, can AQ do multiple instances at once for load distribution?
AQ tables, like it would be created on the owner instance. So whichever instance creates this queue table, it will be the owner. So you can define either that particular owner instance as the primary instance, or if needed, you can give any other instance as the primary instance. So that it depends on the availability of the instance, or else based on the application design. So it depends on that.
Thank you. Another written question would be how to enqueue lost messages.
So to enqueue the lost messages, we have two options available. So if one knows that the messages are not delivered, so we can re-enqueue at the application level. This is the most recommended method. So the application queue table or the original queue table will be having the data. So based on that, we can again re-enqueue the messages. If it is not available, then we can consider taking the backup of a queue table and then re-enqueue the messages later using the manual enqueue procedure. So these are the options available with re-enqueuing the lost messages.
Thank you. If there are no further online questions, I will proceed with the last written question that I have here. What if processed messages are not being removed?
So processed message, it terms that message has been consumed successfully by the target queue or the subscriber. So the message is completely made available to the target. So in this case, a message with a process state doesn't mean any issue. So this simply represents that the queue monitor process, which takes care of the AQ operation, it will spawn up automatically and it will do the cleanup operation. So that is just kind of notification which will be available that these many messages are in process state. And after some time, the queue monitor process automatically it will do the cleanup activity. So once the queue monitor does the cleanup, these process messages will be gone. So this is just like it will be available with kind of logical thing, but the actual message it will be made available to the subscriber. That's it.
Thank you. That concludes our Q&A portion of the session. Thank you for a wonderful session and answering the questions. I'd like to go over how you can locate the recording and Q&A from the session today. Locating Advisor webcast schedule and archives. Doc ID 740966.1 is your starting place to find out about upcoming webcasts or get the recording, PDF, or continue the discussion links for all webcasts. From the drop-down on this page, you can select your area of interest. Here, we'll select Database. You can also go directly to the Oracle Database document where you will be able to see all upcoming webcasts on the Current Schedule tab. For today's event, you can select Archive 2018 tab. You can click on column heading to sort. Hover on webcast title for more information. If you have any questions on a webcast, ask questions via the question link. Recording available within 48 hours. PDF from today's session will also be posted there. The link you see here is for the Oracle Advanced Queuing Features and Administration webcast. Continue the discussion thread. The Q&A from today's webcast will be posted to this thread as well as responses to questions that we do not get to during the webcast. Please use this thread for any follow-up questions you have related to today's topic. To easily keep track of updates to the thread, you can use the following link in the upper right to add this thread to one of your MoSC streams. Selecting the activity link from the top right portion of the screen will take you to your inbox and list all streams you have created. You can also choose to bookmark or like a particular thread. We hope you found the webcast valuable. Please take a moment to share your feedback on this presentation and the webcast program via the survey that will display when you exit today's event. Let us know what topics you'd like to see covered in future webcasts. Thanks to Ragul for Oracle Advanced Queuing Features and Administration presentation, and to Jaya Krishna and Kanti Kiran for joining during the Q&A. Thank you to each of you for taking time out of your day to join us today. We know you have many demands on your time and appreciate you choosing to spend some of it with us. This concludes our webcast today. Enjoy the remainder of the day.